All right, let's get going on today's meeting. So what we're going to do today is we're going to continue to build on what we started last time, which is using SPSS to do significance tests. So last time we introduced SPSS as the program that we're going to be using going forward to do our inferential statistics. And we applied it to the one sample t-test, which is one type of t-test that can be done for one particular experimental situation. And today we're going to double down on that by taking a look at the two sample t-test and how to use SPSS to do significance tests in that particular situation. So again, we are going to be moving forward with developing our skills with SPSS. It is a specialized statistical software package that is used extensively throughout the statistical world. And this is all in service of what we're working on right now, which is inferential statistics. That very important ability to go from a small sample and do correct and intelligent and unbiased inferences to a larger population. Because in the end, it's the population that we wish to serve, not just our sample. So we need an unbiased method to go from what we know, which is the sample, to what we want to impact, which is the population. And today we're actually going to see if we can do 3 do it with me demos. So 3 psychology experiments, classic psychology experiments that utilize the 2 sample design and therefore would be correctly analyzed using a 2 sample t-test. And we'll also take a look at some unexpected, interesting little hiccups along the way, just to kind of illustrate the type of critical thinking that you need to do when you are doing statistics, and also very importantly, when you're reading statistics. Because let's face it, the amount of statistics that we're actually going to do in our careers is going to be minuscule compared to the amount of statistics that we're going to read about in our careers. So we're going to take a small little piece of today to just highlight the importance of making sure that we're reading critically when we do our reading about psychology things. I'm trying to search for a better word, but psychology things I'll have to do. All right, so what's on the schedule for today? We're going to continue our introduction to SPSS, highlighting some more common errors, specifically where's my data. And then I said I was going to give you this last time, but we didn't really need it. The single organizing principle that's going to help you organize your data in SPSS. We're going to introduce it today because today is the first time that we really need it. And then we're going to apply this to do it with me demos. And one thing that I want to make very explicit is that even though the t-test that we're doing is different, the logic of hypothesis testing is not. So those 4 steps that we've been going through, state, plan, do, and conclude, those 4 steps are the 4 steps that we're going to be doing whenever we do a significance test. Some of the details change, but the overall structure remains the same. So that's really encouraging, because once this makes real sense to you, all significance tests will just kind of fall into place, and they'll just be variations on a common theme. So once it clicks, everything will click. And hopefully maybe it'll click today for you if it hasn't already, when we take a look at 3 classic studies. The first one looking at the question of whether or not willpower is a limited resource. Can you actually run out of willpower? Can you actually be drained of the ability to keep moving forward and keep persisting in a task? And then we're going to revisit a study that we introduced early in the semester on whether or not danger can be misattributed as arousing. And then finally, we're going to take a look at a study that addresses the question of whether adults are better than teens at recognizing emotions. So in a social interaction, very important to be able to read other people's emotions accurately. And it could be that adults are actually better at teens, and we'll take a look at a study that tries to measure that and uses a 2 sample t-test in order to analyze the data. All right, so as a brief recap, I mentioned that there are 3 types of t-tests. We've already seen one, the 1 sample t-test. Today we're going to focus on number 2, which is the 2 sample t-test. And the hallmark of the 2 sample t-test, the critical thing that you need to have in order to have a two-sample t-test is right there in the name. You need two samples. You need two separate samples of individuals that are treated in two different ways. So you have sample one, in this case, sample one that is given the drug, and then you have a different group of people, and that's the important part. These are different individuals that are treated differently. In this case, they're given a placebo. So you have one group of people that are given a drug and a different group of people that are given the placebo. You have two separate samples. If you have two separate samples, then you do a two-sample t-test. That is the correct statistical test for this particular design. And as you can imagine, this type of design is extremely popular in psychology studies, extremely useful. And we'll talk about a little bit about why the two-sample design is used, when it's used, and what its strengths are, because it helps to understand why people do these things in order to sort of get that mental framework to hang everything else on. And then as promised, we are going to be going through the same four-step process. So step one, state the hypothesis, state the parameters, the significance level, and the evidence for the research hypothesis. Step two, you're going to plan, identify the appropriate inference method, and then check the conditions. Step three, you do, if the conditions are met, you perform the calculations, calculate the test statistic, and find the p-value. And then finally, step four, we're going to make the conclusion. Make that conclusion about the hypothesis in the context of the problem. Do we reject the null hypothesis and accept the research hypothesis? Do we fail to reject the null hypothesis? You can say accept in this class. Do we accept the null hypothesis and reject the research hypothesis? Make that conclusion so that we understand what our statistics actually means. All right, so this is where we're going to start off the Do It With Me demos. So I'm going to introduce a particular study. We'll introduce the setup. I have a little bit to say about what we're going to be, what we would do. I'm going to say a little bit about why a two-sample design was chosen for each study. But without further ado, let's introduce that first study. So this is a classic study by Baumeister et al. Called Ego Depletion, Is the Active Self a Limited Resource? So imagine that you were watching a very emotionally charged film. So you're watching, for example, a drama, it's a tragic story, and for whatever reason, you cannot show emotion when you're watching this film. For whatever reason, whatever the situation you're in, maybe you're in a group situation where it would be inappropriate to be overly expressive of emotion, but whatever it is, you need to keep a straight face. You need to not react to that movie. The question is, will that assertion of will that willpower to suppress your emotions then impact your other activities later on in that day? So will you actually run out of willpower because you were trying to suppress the emotion? And will that make you less likely to persevere on tasks later in the day? So that was the setup that Baumeister and all wanted to take a look at. We're going to focus in on experiment 3 of their multi-experiment paper. And in this one, they had two groups of participants. And the first group, sample number 1, they were instructed to suppress their emotion. So they would watch a video that was a highly emotional video. I believe it was either a comedy or a drama. It might have been a horror film, but we might just be really close to Halloween, so I got that on my brain. But it was an emotionally strong film. And they were told to watch the video, but suppress their emotion. Do not show any emotion while you are watching this video. So that was sample number 1, the suppressed emotion sample. Sample number 2 was the no regulation sample. They were just given the same video to watch, the same movie to watch, and they were just allowed to react how they wanted to. So if they felt like crying, go ahead and cry. If you felt scared, go ahead and scream. If it was a comedy and you thought something was hilarious, go ahead and laugh. There was no suppression needed. Their natural reactions could just come out. They didn't need to exert any effort to clamp down on the expression of their emotions. So then after these two tasks, what Baumeister et al. Did is they, under the guise of just doing another experiment, they instructed these subjects to try and complete some anagrams. So the subjects were told, hey, this is, we have to wait a little bit here, but this is part of another experiment. If you could just help us out, we have these anagrams. We want to see how many people can solve. Can you solve these anagrams? Can you rearrange these jumbled up words into the actual words that they are? And the anagram task was the dependent measure. And they wanted to know how many anagrams would somebody solve if they just went through watching a movie and having to suppress their emotions versus how many anagrams would somebody solve if they just went through watching the same movie but did not need to suppress their emotions. So would you, in this condition here, would you be just tired out? Would you just have no willpower? So as you're going through the anagrams, you're not really putting in much effort. You're not really trying that much. You're kind of giving up on it. Whereas here, you haven't exerted willpower and now you're kind of fresh. You're feeling good. So you will persist more in the anagrams. If willpower is a depletable resource, then you would expect that this condition here, sample number 2, would complete more anagrams on average than this condition here, sample number 1. So that is what we're going to test. So to test that, we have this file here. If you haven't already, this is available for download in Canvas, or if you're watching this on the video, this is in the description. It's the t-test 2-sample SPSS demo. And this time, you will notice that each page is labeled with large, bold text in terms of the data that is actually there. So we're not going to have a repeat of what happened last time. But just to kind of explain what we're looking at here. So this is the suppress condition. These were the subjects that were told, you need to suppress your emotion. This is the no regulation condition. These are the subjects that were told that they could just express as much emotion as they wanted to. And then each of these scores is how many anagrams each subject solved. So this first subject here, they solved 3 anagrams. The second subject solved 6. This third subject solved 7. And then in the no regulation condition, we have subjects that solved 10 anagrams, 9 anagrams, and 5 anagrams in that particular task. So what we want to do is we're first going to calculate some sample statistics. And we're going to do this. I alluded to this last time, but we didn't actually do it explicitly. This is always something that you want to do whenever you use SPSS, just to make sure, just to kind of double check that you've entered your data in correctly, that you haven't made any mistakes in transferring your data from your Excel sheet probably to SPSS. So what we're going to do is we're going to start off by just calculating some of these sample means. And now that we're in a 2-sample t-test, I just want to show you the convention that is used in order to label each of these. So the sample mean, now that we have more than one, you'll see the little subscript that indicates the group that is being calculated. So in this case, this is the sample mean for the suppressed group. This is the sample mean for the no regulation group. Sample standard deviation for the suppressed group, sample standard deviation for the no regulation group. So when you're doing your homework and when you do this in the real world, always make sure things are labeled. And when you're reading things, always look for the labels. Even though they're subscripts, they're very, very important, especially when we get to the null hypotheses. It makes a difference which one is on which side, and we'll see that in just a little bit. All right, so the sample mean, what we're going to do here is we're going to kind of plan ahead so that we have a general t-test, 2-sample t-test, sample mean, sample standard deviation, sample size calculator. So what we're going to do for here is we're going to calculate the mean. So we're going to use the formula for mean. So we go equals average. And then we're going to open that parentheses. But what we're going to do is, instead of highlighting the scores, we're going to make a general calculator, and we are going to just highlight the entire column by clicking on the column header. So we just click on the column header A here, and that now selects the entire column here. So regardless of how many scores we actually have, we're going to have a formula here that can handle that to calculate the average, which means that if we want to reuse this as a template for further t-test, two-sample t-test, we'll have it ready, we'll have it good to go. So we close those parentheses, we hit enter, we let Excel know that we got it, and we have an average number of anagrams solved by the suppressed sample of 4.94. We're going to do the same thing for the sample mean for the no regulation. So we put average, open parentheses. The no regulation is in column B, so we click on that column B header, highlights all of column B, close up their parentheses, and we see that they solved more anagrams. They solved 7.29. So this is an important, it's a subtle distinction, but it's an important distinction to know about why we do inferential statistics. And I just want to hammer this home a little bit more, because it's very important to realize that this is what takes us from samples to populations. So if we were only interested in these particular subjects, if we were only interested in these subjects that were in this experiment, we're done. And we can very clearly conclude, hey, the sample that did not have to regulate their emotions solved more anagrams than the sample that had to suppress their emotions. So this is evidence that for this sample, for these people, their willpower was depleted in the suppression condition. And that's where it would stop. So we would be psychologists for, I can't remember how many people, for 38 people. And that would be it. We want to be psychologists for 7 billion people. And what we're doing right now with the skills we're developing takes us from the 38 to the 7 billion. So like I said, if we were just interested in the sample, then we'd be done. But we're interested in the population, so we keep going. All right, we're going to do the same thing for sample standard deviation. So sample standard deviation 1 for the standard deviation for the suppressed sample. We go equals STDEV, open parentheses. We're going to keep doing that same thing where we highlight the entire column. And very nicely, Excel will ignore any words that are in the column. That doesn't mess it up at all. So for the no regulation standard deviation equals STDEV, open those parentheses, highlight the entire B column by clicking on the header. You can just hit enter. And then sample size, we want to know how many are in each group. So for this, we're going to use the function count. So we put equals count, and count will count the numbers in the cells that you highlight. So it'll just count how many cells contain a number. That's exactly what we want, because each person has exactly one score. So we open up that parentheses, we click on the column A, hit enter, and we see that we have 16 individuals in the suppress emotions condition. And then we do the same thing, equals count, open your parentheses, highlight that column B, hit enter. You see that we got 14 people in the other condition. So 30 people total, 30 subjects total across these two conditions. And then for the degrees of freedom, we're not going to calculate that. We're going to let SPSS calculate that. So we'll just leave that open there for a moment. But now we have the information that we're going to check against SPSS just to make sure that we've entered in our information correctly. All right, now we go to step 1. And step 1 here, we've already entered in the null hypothesis. And the reason for that is because the null hypothesis, using the convention that we're going to use, is always just equals. Your two population means are equal. So here we have our null hypothesis is that the mean number of anagrams completed by the no regulation population is the same as, equal to, the mean number of anagrams completed by the population of people suppressing their emotions. So it's always about the population. That's why it's mu here. And then for the second null hypothesis here, I just wanted to show this. There's two ways to phrase the null hypothesis in just about every single t-test. And it really just depends on the convention that you're using and maybe a little bit of your own personal preference. So one way is to do what the one that we just talked about, where you say the population mean for the no regulation equals population mean for the suppressed population. Or you can do it in this alternative form where it says that the mean of the no regulation minus the mean of the suppressed population equals 0. And that says exactly the same thing. These two are mathematically equivalent. So this one makes more sense in sort of your natural everyday language of thinking. If somebody asked you, how old are you compared to your twin? You would not say, well, my age minus my twin's age is 3 minutes, right? You wouldn't say that. You'd be like, well, we're 3 minutes apart, right? You use a more natural language like this. So this one makes more sense in kind of a natural language. This one, on the other hand, is technically more of what we're actually going to be testing. Because as you're going to see, what SPSS does and what a two-sample t-test does is it tests against the null hypothesis that your difference is 0. So if you need a reminder of statistically what we're testing, you might want to go with that null hypothesis where it's actually expressing that the difference between the two population means is 0. On the other hand, if I was explaining this to somebody and they weren't a statistician, I would say that the two population means are going to equal each other. That's what the null hypothesis is. But just know that both of these are acceptable. Both of them say exactly the same thing. All right. Now we have to decide what is our null hypothesis, our alternative hypothesis here. And for the alternative hypothesis, we always have to ask ourselves, is this a one-directional test? Is it a one-directional prediction or is it a two-directional prediction? So in this context here, what we would do is we would take a look at Baumeister's introduction. We would take a look at the reasoning that they had for designing the experiment. We would take a look at the previous research that they cited and referenced for this experiment. And if you read that introduction, it is very clear that they are basing their research on previous studies that have shown that ego can be depleted. They have based their research on previous studies that show that exerting your willpower makes you less able to exert it later on. It seems to be a depletable resource. In that case, they would very clearly in this experiment predict that if that was true, if ego is a depletable resource, then the no regulation individuals should be fresher, they should be more persistent in the anagram task, and they should solve more anagrams. So in this case, we would very carefully look at what the subscripts are and say, all right, the no regulation, well, they should complete more greater than the suppression population. So the population mean for the no regulation should be greater than the population mean for the suppressed population. So just kind of think it through. If there's a theory that predicts that you should go in one direction, then have a directional hypothesis. If, on the other hand, Baumeister had no theory, they just said, well, hey, we have this interesting thing that we want to check out. We don't know which way it's going to go. Maybe more anagrams, maybe less anagrams. In that case, you would use not equals for your alternative hypothesis because you don't know if it's going to increase the number of anagrams or it's going to decrease the number of anagrams. Alternatively, if you have two competing theories and they both point off in different directions, so if you had one theory that was an ego depletion theory that said, well, the people that suppress their emotions, their ego, their willpower is going to be depleted, so we predict fewer anagrams. But then you had a competing theory that was called the really angry theory. And it was that if you're suppressing your emotions, you're going to get really angry, you're going to get fired up and charged up, you're going to do more anagrams. If that's the case, you would also use the not equals because it could go in either direction. As it is, though, we're predicting that the no regulation population will be greater than the suppressed population. And then the alternative version of that alternative hypothesis would be then that the no regulation, which is bigger, minus the suppressed, which is smaller, that would be greater than 0. All right, so those are the alternative and null hypotheses. For the alpha level here, oftentimes in a paper, you'll see the alpha level directly reported. In this paper, I did not see an alpha level that was actually reported. If the alpha level is missing, then you can very much assume that it is 0.05. So if your alpha level is not directly stated, 0.05 is what you can 99 out of 99.1 times assume that is going to be the alpha level that is being used. If an alpha level other than that is being used, they are most of the times very explicit about saying we're using an alpha level of 0.01. So if you don't see an alpha level, 0.05 is the default. And then finally, we have evidence for the alternative hypothesis. And here we have that the no regulation mean minus the suppressed mean. And we're going to just do the general form of this. We could actually figure this out because we do have the mean for no regulation. We do have the mean for suppressed. But the evidence is the fact that the mean for no regulation is larger than the mean for suppressed. So no regulation minus suppressed would be greater than 0. So we actually have evidence for the alternative hypothesis. Now we're going to see if we can actually run this test and whether or not we can generalize to the population. All right, so first thing to notice here, we're going to go down to the large sample one because that is easier to answer. In terms of large sample for step 2, which is check your conditions, in terms of large sample is defined as 30 or more. So for the no regulation, that's actually a no. And the large sample in a 2-sample t-test applies to each sample. So the fact that both of these add up to 30 does not matter. Each of them has to be 30 or more. So in this case, we have a large sample for no regulation, and we do not. And do we have a large sample for the suppressed condition? That's why we calculated these over here. We do not. So in this case, we would not feel confident going forward unless we knew that these came, that these were, well, actually, hold on a sec, I'm getting around myself. Were they randomly selected? Yes, they were both randomly selected. Did they come from a large sample? No, they did not come from a large sample. And this was a holdover from last time because it's either large sample or they come from a normally distributed population. So if you want to update your Excel files there. So the question again is it a large sample or is it normal? And in this case, we don't have large sample, but if we take a look at the distribution of the sample and we ask ourselves, how is willpower determined? We actually do have evidence that it should follow a normal distribution in the population. Because if you take a look at the evidence or the research on willpower, there are numerous factors that go into willpower. There's things like learning history, there are genetic predispositions, there's whether or not you got a good night's sleep the night before. There are multiple differences and multiple factors that contribute to willpower. And if there are multiple factors that contribute to something, most often that thing is going to be normally distributed. So we don't have that large sample, but we probably have a normal distribution. So we can hit yes on those two, and we have the condition satisfied, so we can go forward with our test. All right, so now we get to step 3. We're actually going to calculate that. And for that, we are going to go back to SPSS. So if you haven't already, log into IU Anywhere and open up SPSS. And if you missed last class, we are just going to go and search for IU Anywhere, and that is where as in software, W-A-R-E. It's all one word. And then we click on IU Anywhere Assessment and Instruction Tools. We click on the IU Anywhere login. You log in with your IU credentials. You got to use the @ sign for the email name. Enter in your password. Enter in your Duo mobile code. That's all the security. Do not stay signed in because you're on a public computer. And then instead of detecting the workspace, we're going to use the web browser. And typically it would pop up here on apps. So if this is your first time using it, click on apps over here. You can search the workspace for SPSS. In this case, I got SPSS up here. Make sure that it is highlighted with the favorite star there, because then it'll populate it on your home page. And then we just click on SPSS and it will launch that resource and we will have that good to go.
3 hours later.
All right, so while we're waiting for this, just a little observation on why a two-sample design was used for this particular experiment. One of the reasons two-sample designs are used is when carryover effects are a factor in your experiment. So if asking somebody to do something twice is either going to introduce too much fatigue, or participating in the first condition is going to impact your participation on the second condition, that is a time when you want to use a two-sample design. So in this case, if somebody was ego depleted after watching one movie and then they did an anagram task, and then you put them in another movie and let them not suppress their emotions, well, they're already tired. They're already fatigued. That's carried over from the first session. So you wouldn't want to do it in a before and after type design. So in this case, the two-sample design was the correct design to use in order to get the most accurate results. All right, so now we have our data editor, data view. So what we're going to do is we're going to go back to our Excel sheet here, and we're going to start off with the suppress sample. So highlight all of those, click on the top one, Control Shift, down arrow key, Control C to copy, and we are going to allow. And then we can just go over here to IBM Statistics, SPSS, click on that first cell, Control V, we'll hit allow, it'll paste in a V. We will highlight that and we will delete it. And now we'll do Control V for real. And there we go. So we have our scores for our first sample in SPSS. And we are going to go to variable view and we are going to rename this, not var 00002, that's a horrible name. We're going to call this one anagram. So anagram, because this is how many anagrams did they solve. This is the anagram score. So we're going to call that anagram so that we can remember it when we come back to this, if we ever do at another time. So now we have the scores for the first group of subjects. And the question becomes now, where do we put our second group of subjects? Where do these guys go? Because we got to put them somewhere in SPSS. We got to give SPSS something, these numbers somewhere. So the question is, well, do they go in the next column over? And we'll just let SPSS know that column 1 is the suppression group and column 2 is the no regulation group? Or do they go down here underneath, and then we'll somehow tell SPSS that rows 1 to 16 are the suppression group and rows 17 to 30 are the no regulation group? Well, it can get a little bit confusing where you're supposed to put this in SPSS. And this is when I'm going to give you the one rule that will help you organize your data in SPSS more than any other rule, and it is this. In SPSS, every single row belongs to one and only one subject. So every subject in your experiment gets one row all to themselves, and they only get one row all to themselves. So this row here, that entire row is for subject 1 in the suppress sample. This entire row is for subject 8 in the suppressed sample. And what that means is when we're looking for a place to put our regulation sample, well, they need to get their own rows. They can't share rows with the people in the suppression sample. So the only place that they can go where they're going to get their own rows is right down here. So before we paste that information there, though, just so that we don't get confused, we're going to label which group this is part of, and that we're going to do in the next column over here. So what I want you to do is just to label which group this is, and we're going to call this one suppress. And you can see that SPSS in that top of this column has recognized this as a word. So remember we talked about that last time. SPSS will recognize things as either numbers or words. So you could just write out suppress 12 times, or sorry, 16 times. That would suck if we had, 400 subjects. You could Control C, Control V all the way down. But a much quicker way is to just Control copy one of the incidences of suppress, and then with your Shift and arrow keys, highlight the rest of them. And then you can go Control V, and it'll auto-fill the entire highlighted area. So that's a much quicker way to get all of those labels in. But we need those labels there so that SPSS and us will know that this group here, all of these subjects, they belong to the suppress emotions condition. All right, so that's the suppress emotions condition. Now let's get the other group in here. So we highlight their scores, we copy, we go over here, we go in the first column. Now on the 17th row, the first open row, we hit Control V. Now we have the no regulation subjects in there. And we are now going to label this. And one thing that I'm going to caution you when you're choosing your variable names and your group names, one thing that I will caution you is try as much as you can to limit it to 8 characters. Because if you limit it to 8 characters, your tests will run correctly regardless of what version of SPSS you're using. If you go over 8 characters, you take your chances. So while I would love to just type in no regulation on this one, I'm just going to go with no reg. And that should be enough. And then, well, it's enough to jog my memory that that's a no regulation group. And then we're going to fill that down. So remember to Control C, copy the cell that has no regulation in it. Highlight the cells that you want to label. Control V to put them down. And now we have our data properly formatted, ready to go in a format that SPSS is going to understand. Is everybody at that point? We're good? Okay. So now we're good to go. So we go back here to analyze on the toolbar control panel here. We go to analyze. We're still in compare means and proportion. So we're gonna be camped out in this particular menu option for a while. And then this one is a little less friendly than the one sample t-test, because last time we were doing a one sample t-test and we saw, hey, look, we got one sample t-test right here. For this one, it's the independent samples t-test. So independent samples basically means you have 2 groups of individuals, 2 samples, and they're not the same people. They're independent. So 2 samples, independent samples, same thing. So again, analyze, compare means, independent samples t-test. We click on that, and now we come to this window. And here is where we will enter in our test variables and our grouping variables. So one thing to always remember is that SPSS is not going to let you do certain things with certain variables. The other thing to remember is I jumped a step. This is still var 00003. That's a horrible name. So let's go to variable view, and we're just going to call this group, because that's what it is. It lets us know which group is each subject is in. All right, now we go to analyze, compare means, independent samples t-test. Now this one makes more sense where I'm looking at anagram and I'm looking at group. And what I wanted to mention is that SPSS is not going to let you do things with group that it's going to let you do with anagrams. So if we went to group and we said, hey, put that in the test variable, SPSS is going to say, can't do it. Can't do what you want me to do with that string variable. So if this occurred with the variable anagram, that means that you have a word somewhere in your column. You need to delete the whole thing and just start over. That's usually the easiest thing. But in this case, we did it right. So we're going to move anagram over here to the test variables. And then group is going to go into the grouping variables. And then SPSS says, all right, you're going to give me two groups. What are they called? What are their names? So this is where we're going to hit define groups. And what I'm going to do first is I'm going to do it incorrectly. So don't follow me yet, just so that you see what happens. So let's say that I'm here and I'm saying, all right, let's put suppress into group one. And let's say that I forget how to spell and I just miss one of the P's, right? Spell it wrong. And in my second group, I'm going to put in no reg. So this is how SPSS is going to identify the groups. So I hit continue, I hit OK, and lo and behold, SPSS is giving me this, saying independent sample table is not produced. There's no information. There's no two sample t-test. So in this case, you want to take a look at your group statistics. Take a look at the information that SPSS gives you because it's usually extremely helpful. And you can see that, well, in my no regulation, I had 14 subjects, but in my suppressed group, I had 0. No, I'm supposed to have 16. So you double check, you notice that, oh man, I spelled suppress wrong. So we close this out. We don't need to save it. We go back to analyze, back to compare means and proportions, back to independent samples t-test. We're going to click on the grouping variable. We click on define groups again. We're going to add the P. So now you can follow along. We're going to put suppress as group 1. We're going to put no reg as group 2. So again, just double check that you've spelt it the same way that you did when you labeled the groups. And then we hit continue and we hit OK. And then this is the output that we get. And this is where I'm going to point out one of the hiccups that will occur when you're using SPSS. So this is going to be a little bit of a full confession for me. I use SPSS all the time. I love SPSS, and I still cannot remember whether they go group 1 minus group 2 or group 2 minus group 1. I will never be able to remember that consistently. So what you want to take a look at is that you have the no regulation and it has a higher mean than the suppression group. So in our directional hypothesis test, we are looking for a positive difference. We're looking for no regulation is higher than the suppression group. And in a positive difference, we're looking for a positive t statistic, and we should get one. But notice here that our t statistic is negative. If the t statistic is negative, but it should be positive because your no regulation group is higher and we're testing for higher, then what I would recommend is just cancel out, close this down, no need to save it, go to analyze, compare means and proportion. You're getting a triple dose of this today. Go back to your defined groups and let's just switch those. And we'll put suppress in the bottom. We'll put no reg. Whoops, we'll spell no reg correctly in the top. So we'll just switch them around. We'll hit continue. We'll hit OK. And now we have the exact same numbers, but they're just mirror reverse, right? We have the exact same numbers and now they're positive instead of negative. It just takes one last little piece of mental gymnastics out of your mind that you need to do. But now we have this output here. Does everybody have that? Does everybody have those numbers? All right, let's take a look at what those numbers are actually telling us. I actually had no regul when I did this previously. All right, so we have these numbers here. And now we're going to take a look at where can we find the information that they have reported in their study. So this is the actual statistical report that Baumeister et al. Gave us. So participants in the suppressed emotion condition performed significantly worse than participants in the no regulation condition in terms of number of anagrams correctly solved. T with 28 degrees of freedom equals 2.12, probability less than 0.05. And then we have the success at solving the puzzles. The suppression group solved 4.94 anagrams with a standard deviation of 2.59. No regulation solved 7.29 with a standard deviation of 3.52. So now let's see where they would have gotten that information. So first off, check your group statistics. This is your insurance policy against making errors. And what you want to do is you want to take a look that each sample has the right number of individuals, has the right mean, and has the right standard deviation. So we would compare that to our Excel sheet, and we would simply say, well, in Excel, we had a count of 14. We had a mean of 7.29. We had a standard deviation of 3.52. That's exactly what we have here. So we know that we put that sample in correctly. Because one of the things that is real easy to do, is to just have one extra suppressed person. When you're pressing down, when you're highlighting and you press that control down, sometimes you just go one too far, and we don't want to not catch those errors if they're made. So make sure that you double check your group statistics. So we check it for the no regulation. We then check it also for the suppression condition. So we have 16 individuals, exactly what we wanted. 4.94 for the mean anagrams, exactly what we wanted. 2.59 for the standard deviation, exactly what we wanted. And incidentally, this is where Baumeister and all would have gotten their data from similar calculations. All right, so now that we know that we've done things correctly, we can move forward with confidence, and we take a look at our independent samples t-test. Now, for the independent samples t-test, the first one we're going to take a look at, we're going to stay in this top row here. I'm just going to mention that 90% of the research that you read is going to be in that top row. 10% of the research that you read approximately is going to use the bottom row. When you take stats in grad school, you'll be very highly explained in terms of what's the top row, what's the bottom row. It's not really necessary for us in this introduction to statistics course. Using the top row, you will not go wrong using the top row. Using the bottom row, it's a little bit more powerful, but it is a little bit more complicated. We will see an example of it today, but for this one, Baumeister, they stuck to the top row. Equal variance is assumed, and they have a mean difference of 2.34. That mean difference is the difference between your two samples. So the difference between the number of anagrams solved in the no regulation condition, 7.29, minus the number of anagrams solved in the suppression condition, 4.94, that gives you your 2.34 mean difference. And then you can also have that 95% confidence interval of the difference. So when you're taking a look at these confidence intervals that are calculated in SPSS, know exactly what they're giving you. Because what they're giving you is the confidence interval of the difference. How big is the difference between these two individuals? And I can say with 95% confidence that the no regulation condition scored at least half an anagram more and up to, scored at least 0.5 of an anagram more and up to 4.5 anagrams more than the suppression condition. That's what I'm 95% confident about. But if somebody was to ask you, well, can you give me a 95% confidence interval for how many anagrams the no regulation group solved? That's a different question. SPSS did not calculate that. It calculated the difference, not the actual values for each sample. So just be aware of that. We have a 95% confidence interval for the difference. All right. So now let's get to the meat of the actual significance test. There's your T statistic and degrees of freedom right there. So 2.098 is what was calculated, degrees of freedom 28. And then this was a one-sided t-test because we had a direction that we were predicting the data should go. So we would report the one-sided p-value of 0.023 for our statistical test. So in that case, let's go back and we will, where did it go? We will go here. We will go back to our information here in our Excel sheet, and we have a t-statistic of the difference, and that was, let's go back to our output here. That t-statistic was 2.098, so we can round that off to 2.10. So we put 2.10 just to have all our information in one place. Degrees of freedom, SPSS calculated that was 28. P-value of the difference, SPSS calculated that. We're using a one-sided p-value, so 0.023. So now we want to do our final decision. Do we accept or reject the null hypothesis? And this is a very good sort of decision thing to write down until you get it. It's kind of solid in your mind. Have it written out. If your p-value is greater than alpha, you do this. If your p-value is less than alpha, you do this. So if your p-value is greater than alpha, you accept the null hypothesis, you reject the alternative hypothesis. If your p-value is less than alpha, then you reject the null hypothesis and you accept the research hypothesis. So 0.023 is less than 0.05. Our p-value is less than our alpha. So we are going to reject the null hypothesis with black ink, and we are going to accept the research hypothesis. And our conclusion is that there is evidence that the suppressed population solved fewer anagrams than the no regulation population. All right, so one little hiccup that I want to point out for this one is there is a bit of a mismatch between the numbers that we actually got and the numbers that Baumeister et al. Actually had. So the things that were the same, the things that our SPSS analysis and their statistical analysis did exactly the same. The t-statistics and degrees of freedom, the degrees of freedom reported right there, exactly the same. The p-value, you can tell this is an older study because they have a p-value less than 0.05. What that tells you when you're reading this is, number one, the p-value was less than 0.05. We don't know how much smaller it was, but it's less than 0.05. The other thing this tells you is that their alpha level for sure was 0.05 because that's all that mattered to them. Is your p-value less than your alpha level? So we know exactly what the p-value was. It was 0.023. They calculated what it was, but they might have only known that it was less than their alpha level, which is good enough. But then we got this little, and we have the sample statistics here that matches our data as well. The only thing that was off was this 2.12. We found 2.10, and that was probably a rounding error that occurred because when I was generating this hypothetical data, I rounded it down to whole numbers, and it was very difficult to get that exact. So if you're wondering, hey, where's that mismatch? That's what happened. It was just a rounding error. But everything else would have been exactly as Baumeister et al. Would have done it. All right. So that was the study on suppression of emotion, and it does ego, is ego depletable resource. Any questions on that or comments? So I want to, we haven't had a chance a lot in this course to kind of take a look at some of the implications for some of the things that we have been studying. But I did want to point this one out because this one has some very important implications that go beyond the subject matter of the experiment. So it's always important whenever you see an experiment like this or whenever you're reading about psychology experiments to think about how does this impact people in the real world? What kind of an application might this have? Because really the situation that these subjects found themselves in, where you're watching a movie and you're told to suppress your emotions, is such a rare instance. I can't remember the last time that I was watching a movie. No, actually, the only time in my life that I was watching a movie and I was suppressing my emotions was when my daughter was young and I didn't want her to freak out too much when scary things were happening in Coraline. So I had a big smile on my face when I didn't want to have a big smile on my face. But that was really like the only time, right? Just to kind of reassure her, yeah, this is fine. That's the only time I ever had to suppress my emotions while watching a movie. So why is this such an important study? It's an important study because it shows the impact of suppressing your emotions in general. It provides evidence that suppressing your emotions depletes your ego and it depletes your ability to then do things later on in your day. So, what this means is that if you can at all help it, get yourself a job, get yourself a career where you do not have to suppress your emotions because that will take a toll on you day after day after day. In fact, if you need to suppress anything about yourself, that will take its toll. So just know that going in. If you need to act a certain way in a job situation, if you need to dress a certain way in a job situation, if you need to make sure that you're not smiling too much, or maybe that you're smiling enough in a job situation, that's going to take its toll on you day after day after day after day. You're going to have your ego depleted. And while other people come home from their work and they're fresh and they're good to go, and they're able to say, for example, go to an 8-hour shift and then go to night school because they weren't suppressing their emotions all day and they're now able to do their night school anagrams. If you are in a situation where you just have to do what is known as emotional work throughout your day, just know that you're going to be wiped out at the end of the day. So if at all possible, find yourself a job environment where that suppression of emotion is minimal. You're going to have to suppress your emotions sometimes. It's probably not a good idea to fly off the handle at your boss, even if they deserve it. But then also, when you're the boss, try to create an environment where people don't need to suppress their emotions, where they can be themselves and not have to put in effort to fit into boxes that might not be right to contain them, because then they'll have more energy to devote to the work, to devote to improving themselves afterwards, and it'll just be better for everyone. All right, that was my public service announcement for Baumeister. The last one we're going to do today, and then we're going to continue on with another two sample t-test next time we meet. But the last one we're going to have time for today, we're going to revisit the Dutton and Aron study, some evidence for heightened sexual attraction under conditions of high anxiety. So hopefully you recall this study. This was a study where subjects were approached by an interviewer while they were crossing a bridge. So they were male subjects, and the male subjects would cross a bridge, and we're going to take a look at the data where the male subjects were approached by a female interviewer, and they were crossing the bridge, and the interviewer would simply ask them, "Hey, can you complete a survey, for me?" And if they said yes, one of the questions that they would be asked is they would be shown a image, a photo, and they would be asked to write a short story about that image. And the image that they used was from a test called the thematic apperception test. And it is basically a kind of Rorschach-like test where you take a look at a picture and then you come up with a story, and then that story is analyzed later on. And in this case, it was a black and white photo of a woman that had one hand covering her face and then one hand reaching out. So an ambiguous picture, they would show it to the person, they would say, "Hey, can you write a short story about this image?" So sample number one was the control sample. And this sample consisted of subjects that were crossing a very stable, very well-built, very fortified bridge. Sample number two, on the other hand, was crossing an infamous rope bridge, and this was the experimental sample. So they were still approached by the experimenter, still approached by the interviewer, still asked to do the story, and they were, however, on that rickety bridge. And this is another example of a situation where a two-sample design is required and a two-sample t-test is required, because it would make no sense to go to somebody who's crossing that stable bridge. It would make no sense to go to somebody that's crossing that stable bridge, ask them if they can do an interview, hand them the picture, say, can you make a story about this picture? They say yes, they finish the story, and then they end up crossing the bridge. You then catch up to them and say, hey, if you can just help me out one more time, can you cross that bridge over there and I'll meet you halfway and we'll do this whole thing over again? If you did that, they'd probably think that you had some memory problems or something, or they were being punked or something weird was going on. Participating on the first bridge would impact their responses on the second bridge. So a 2-sample design was required for this particular test. So what did they analyze in the thematic apperception test? Well, what they did is they had independent coders take a look at how many sexual situations, how many instances of sexual imagery were in the stories of this, about this woman who was covering her face with one hand and reaching out with another. So was there no sexual imagery? For example, this woman, I'll make up a story about her. All right, she was jogging and, she was jogging with a friend and then a bee stung her in the face. So she's covering up her face with her arm and she's reaching out to her friend saying, hey, wait up, I just got my face stung by a bee. That would be something with no sexual imagery whatsoever score. On the other hand, you could have another one where it would be like, this girl was jogging with her friend and her heaving bosom and sweat glistening off her, her voluptuous, and that one would be scored very highly. So how did they score on the 2 different bridges? Well, let's take a look. So for this one, we're going to leave Baumeister and we're going to go down here and we're going to click on Dutton and Aron. And now we have this very nicely labeled, and we have Dutton and Aron, some evidence for heightened sexual attraction under conditions of high anxiety. So what we're going to do here is, remember how we were setting up Baumeister et al. Over here? Well, we're going to use that to our advantage for Dutton et al. Over here, because these two are basically set up in the same columns and the same rows. However, Dutton et al., they have a different number of subjects here. So what we're going to do is we're going to go to Baumeister et al. And we are going to highlight all these functions here. And remember, we coded them in a way that they're doing the mean, the standard deviation, and the count for the entire column. So we are going to copy those, Control-C. We're going to go over here to Dutton and Aron. We're going to go to the same area, right? So H6, we're just going to make sure H6 is where it was there. H6 is what we have highlighted here. We hit Control-V, and now we have sample mean for the experimental group, sample mean for the control group, standard deviation for the experimental group, standard deviation for the control group, number in the experimental group, and number in the control group, all calculated instantly. We can double click on those just to make sure that they are doing the right columns, but they are correct and they're good to go. So now we have that all set up. All right. So what we're going to do is we will, just kind of looking at the clock here, we're going to do this halfway, and then we're going to come back next time. We're going to finish the other half. So let's do step 1 and step 2, and then we'll do the calculations next time, because I don't want to rush it too much, but I do want to kind of cover some ground on this before we go. All right, so null hypothesis. Once again, 2 different ways to say the null hypothesis. Once again, null hypothesis already filled in because the null hypothesis is just equals. It's just that the 2 populations are equal. So in this case, what the null hypothesis is saying is that the sexual imagery score for the story from the experimental group is going to be equal to the sexual imagery score from the control population. So again, these are for populations. So the population of individuals that crossed the rickety bridge, they're going to have the same sexual imagery score as the population of individuals that crossed the wooden bridge. And that is the exact same thing that's said over here, except it says that the difference between the 2 population means is going to equal 0. Next one here, we have the alternative hypothesis that the population mean for the experimental group, the group on the rickety bridge, is going to be what compared to the control group? So this is where we need to ask, is this a two-directional hypothesis or is it a one-directional hypothesis? And it's a one-directional hypothesis if Dutton and Aron had a theory that they were working with that predicted a specific direction. And as it turns out, they did. They had other studies previously that showed in situations where you had to deal with aggression, situations where you felt like you were in danger, situations where basically you were in a high intense environment. Those situations led to increases in your feelings of arousal. So they knew, they predicted that in this experiment, the rickety bridge would cause more arousal. The experimental condition should have more arousal, and that arousal was measured by the sexual imagery. So the more aroused condition should have more sexual imagery. Experimental condition should be more aroused. So we have experimental condition greater than control condition as our alternative hypothesis. And then here for alternative hypothesis version 2, we have the sexual imagery for the experimental population. Because it's bigger, if you take away the mean for the control population, that should be greater than 0. So we have that as our alternative hypothesis. Alpha level 0.05. Once again, it wasn't explicitly mentioned. And the evidence for our alternative hypothesis is that the mean of the experimental sample minus the mean of the control sample is going to be greater than 0 because the mean of the experimental sample is larger than the mean for the control sample. All right, so we're gonna we'll do just a little bit more. You know what? No, we're gonna end it there. We're gonna do step 2 next time. I just want to mention one more thing here, and this is again the kind of like non-statistical hiccups that come across when you're doing statistical work. So if you remember when we were talking about Baumeister et al., we had 2 nice labels for the samples. And it was really easy to talk about and think about the no regulation population and what that represented, the suppression population and what that represented. I just realized I misspelled suppress on this on this Excel sheet. I'm not a spelling whiz. But anyways, it made it a lot easier to think about it. And when we took a look at our SPSS output, we have here no reg, we have here suppress. We know what groups those are in. We don't have to do that second step in our mind to kind of remember which group is which. On the other hand, Dutton and Aron, they called their 2 groups, and I use this language because it's what's in their paper. They used experimental group and control group. And that is 100% correct, but it is 100% difficult for your mind to work with because even as I was talking here about this study, I kept having to remind myself experimental group, rickety bridge, control group, wooden bridge, experimental group, danger, control group, safe. So it would have been way easier if they just called this rickety versus stable, right? Or danger versus safe, right? If they did something like that, then when we were talking about the mean of the danger population equals the mean of the safe population, it just would have been a whole lot easier for ourselves to track. So we're going to stay with experimental and control because that maps directly onto the language that they used. But just for your own experimental designs and when you're labeling your own research, be as friendly to your mind and other human minds as you possibly can. Label as something that makes it easier to think about. So be less like Dutton and Aron and be more like Baumeister, where they said, yeah, the suppression condition, the no regulation condition makes way more sense than the experimental versus control condition. All right, so any other questions about anything that we covered today? All right, so next time we meet, we are going to dive right back in to the 2-sample t-test. We're going to take a look at the Dutton and Aron analysis, and then we're going to do the analysis on the recognition of facial emotions amongst teens and adults. If you would like to, I would recommend you can practice doing those ahead of time so you have the setup for the Dutton and Aron and the scores available here. And then the Lee et al. Is the one about the perceived facial affective ambiguity. So you're not going to know whether the step one alternative hypothesis should be non-directional or whether it should be directional unless you read the paper. And I'm not expecting you to do that. But if you want to just try the t-test, just set it up with the scores that you've been given and give that a run. And then when you come in, you can see if your scores match what we do live in class. That would be a really good way to know if you're grasping this information, if it's sinking in, and if it's really something that you are going to be able to do independently. So if you got some time, give that a shot, give it a try. But other than that, if there's any questions, all right, we are done for the day.